Hello everyone, my name is K. Rajesh. I am from CSC B section. My topic is about current use of Linux in spacecraft flight software. Introduction. Spacecraft onboard computers are responsible for controlling the spacecraft platform, payloads, or other onboard devices. These, their mission-specific software allows communication with ground or other onboard computers. Traditionally, onboard software has been written close to the hardware in assembly language ADA, C, or C++, with or without a real-time operating system (RTO). As spacecraft computer hardware capabilities are increasing, spacecraft software is becoming larger and more complex, handling more tasks from payload data processing to landing a first stage of launch vehicle to an ocean-going bridge. Spacecraft will still continue to include very small embedded systems that can be developed without operating systems, but some systems will also have large software bases requiring effective software development processes and reuse of existing software modules. The last decade has seen increasing use of Linux in spacecraft on board softwares. Spacecraft on board computers. Spacecraft on board computers are responsible for handling telecommands sent by ground, providing telemetry to the ground, processing onboard data, and controlling the spacecraft platform and payload devices. The spacecraft may have one or several onboard computers that handle different tasks. Similarly to other embedded computers, a spacecraft onboard computer usually has at least a processor, random access memory, read-only memory for boot code, mass memory, database interfaces, and power supply. Perhaps, unlike many other embedded computers, some parts of the onboard computers may be made redundant to any possible hardware malfunctions. Radiation hardened SPARC, PowerPC, MIPS, and Intel x86 architectures have been popularly in traditional industrial and governmental space applications. University small satellite missions have tended to use a large variety of processors, especially from the ARM family. According to a 2010 analysis, low-power microcontrollers such as Microchip's PIC series and Texas Instruments MSP series have been popularly in CubeStar before 2010, while ARM microcontrollers was becoming more popular due to their greater processing power. Some inexpensive commercial off-the-shelf COTS microcontrollers such as the Texas Instruments Hercules family have safety critical features previously usually seen in expensive high reliability processors to making them active for space applications. Spacecraft onboard software. The onboard software running on the onboard computer is responsible for utilizing the computer's hardware resources and interfaces to achieve its specified mission, such as controlling the spacecraft or some platform or payload instrument. Onboard software must typically provide at least a telecommand and telemetry interface that is utilized by ground control of some other onboard software running on other onboard computers. Onboard software can be roughly divided into three parts. Hardware driver software for providing abstractions of the underlying hardware, operating systems for providing task and resources management, and application software for providing the mission specific functionality. This division is illustrated in figure. So, some simple onboard software may not need an OS at all. Embedded Linux. The term Linux strictly refers to the operating system kernel originally developed by Linux terminals since 1991. Linux is used in embedded systems because of quality and availability of code. wide hardware support, implementations of communication protocols, and application programming interfaces, available development tools, provable license conditions, vendor independence, and cost. The Linux kernel can be run in various Linux systems, from very small embedded computers to supercomputer clusters. Each system has a different purpose and different software packages and applications. Linux has been ported to many architectures. As of this writing, the Linux kernel README files list at least 22 supported architectures. According to Yogmer architectures, mostly used in embedded Linux applications include ARM, AVR32, Intel x86, M32R, MIPS, Motorola 68000, PowerPC, and Super H. Linux is also available for the LEON processors commonly used in the European space industry. Thus, Linux is available for most of the architectures commonly used in space applications. Linux in orbit. This section reviews Linux use in various spacecraft. The analysis is limited to the selection of missions that have academically published their Linux use. The selection includes educational, governmental, and commercial missions. More than 100 spacecrafts, many by Plant and SpaceX, have flown through Linux. Po- Possibly the first study of using Linux is in spacecraft dates to the NASA Flight Linux project that ran from 1999 to 2002. The project aimed to provide an on-orbit demonstration of the Linux operating system. The demonstration target was to use a 12 satellite operated by Surrey Satellite Technology Limited. Many CubeSat missions, including the Alto 1 mission in development at Alto University, have, have used Linux in their flight computers. Alto 1 uses a AT91 RM9200 based computers with a customized 3.4 kernel prepared using build root. However, this analysis only focuses on successfully flown missions. Alto 1, shown in Figure 3, is expected to be launched in early 2017. QuakeSat. One of the earliest CubeSat to fly Linux was QuakeSat, which was a 3U CubeSat satellite built in Stanford University for QuakeFinder LLC. It aimed to study extremely low frequency magnetic signals in order to possibly predict earthquake activity. QuakeSat also aimed to demonstrate the usefulness of commercial of the shelf electronics and the CubeSat standard for the development of low-cat space missions. QuakeSat's command and data handling systems operated with timed commands to perform payload data gathering when historically active earthquakes areas were within the range of the instrument. Dove satellite. Formerly Planet Labs, aims to provide high resolution imagery of the whole Earth at high refresh rates by using constellations of tens to hundreds of the CubeSats. The Dove satellite family used to planet consists of three units: CubeSat that are in efficient effect telescopes with cameras, support electronics and attitude control. Two Dove satellites are shown in the figure 4. Planet has extensively used components from the smartphone industry to compress the electronics to a very large size, thus making the much room as possible for the camera optics. Like smartphones and other consumer electronics, planet does not use separately boxed electronics, but all the spacecraft electronics are integrated to the single package. Each satellite is very low cost and expendable. There is thus a satellite level redundancy built into the constellation. SpaceX, founded by Elon Musk in 2002, operates the Falcon family of launch vehicles and the unma- unmanned Dragon spacecraft. Falcon 9, shown in Figure 5, is a commercially operated or- orbital launch vehicle. Dragon, shown in Figure 6, is currently used to supply the International Space Station, and is planned to be mandated in the near future. The goal of the company, as stated by Elon Musk, is to eventually establish human presence on Mars. SpaceX also accepts the greater availability of hardware leads to greater familiarity with the systems, thus reducing bugs. Flight software developers have several of the flight computers and their desks. They are also interacting and developing new versions of the computer to be used in further missions and aim to learn for the experience. Developing new versions of the computers also allow using the latest parts available in the market. New industrial grade parts become available much more frequently than radiation hardened parts. Conclusion: it was found that Linux has several benefits for spacecraft software development, including availability of source code and development tools, large user community, and pool of developers deployment across several industries, thus leading to the off-the-shelf availability of many utilities and software. The support of many types of hardware. Platform-independent Linux targeted software could even be developed and used across various missions. However, before Linux it is to be used, question that need to be considered include limiting hardware selection mostly to 32-bit and 64-bit architectures, uncertain and unstandardized hard real-time capabilities, and possible presence of unused software modules that only consume resources without additional values. Thank you.